Hello everyone, good evening. So here we will solve some more JEE Mains previous year uh, questions on the chapter Simple Harmonic Motion. Any doubts, if you have any steps, please write that in the comments. We shall obviously clarify them, and in any other chapter of physics, any difficulties you have, then please write that in the comments also, so that we can be more priority on it and solve more and more questions of that chapter. Also, please install our Sapience education application, where we shall upload some important questions based on every chapter of physics. And the, the link of the Sapience education application has been provided in the description. Here it is told that mass M attached to free end of a spring executes SHM with a period of 1 second. If the mass is increased by 3 kg, the period of the oscillation increases by 1 second. The value of mass M is mass M attached to free end of a spring executes SHM. Mass M attached to free end of a spring. Constant K executes SHM with a time period of 1 second. If the mass is now increased by 3 kg, the time period of the oscillation increases by 1 second. So if the mass is n plus 3, then the time period will be 2 seconds. The value of the mass n is how much? That is asked. Now T, we know T is equal to 2 pi root over 2 pi root over n by k. Now T1, T2, spring constant is same. So T, I can say T is proportional to root time. So T1 by T2, that is equal to root M1 by M2 means why T is directly proportional to root time. Now M1 is M and M2 is M plus 3. So it means 1 by 2 is equal to 0 over M by M plus 3. So then you can square both sides. So it will be 1 by 4 equal to M by M plus 3. So M plus 3, that is equal to 4M. 3M is equal to 3. So M is equal to 1. So the value of the mass M is 1 kg. 1 is the answer. Then it is told a block of mass M is attached with 2 identical springs of spring constant 20 Newton per meter each. A block of mass 2 kg is attached with 2 identical springs that spring constant 20 Newton per meter each. So here also the spring constant K is 20 here, and here also the spring constant is 20 here. Therefore, and then the block is placed on a frictionless surface, and the ends of the springs are attached to 2 rigid supports. In the mass is displaced from its equilibrium position, it executes simple harmonic motion. The time period of oscillation is pi by root x in SI unit. The value of x is. So now here the equivalent spring constant will be 2k, that is 40 Newton per meter. The time period of oscillation will be 2 pi root over m by k equivalent. So that is 2 pi root over m, that is 2 kg divided by 40. Into 20, that is 40. So you can say it's 2 pi by root 20. Now root 20 is 2 root 5. 2 pi by 2 root 5. So it is pi by root 5. It's equal to pi by root x. Therefore, x is 5. The value of x is 5. So the time period is pi by root 5 seconds. Then it is told the time period of oscillation of a simple pendulum of length L suspended from a rope, suspended from a roof of a freedom, which moves without friction down an inclined plane. Angle of inclination alpha is given by. So it is the car or the vehicle is moving down the inclined plane, and one simple pendulum is attached to the roof. So, so it moves in an inclined plane of inclination alpha. Now here the acceleration will be g, moves without friction. So friction is not there. So g sine alpha is the acceleration. So therefore now the drop of mass m, the drop of mass m on the roof, that will have an inclination at equilibrium. You have an inclination at equilibrium, that is theta. Since here the mg sine alpha is the pseudo force which is acting, since it is an the vehicle will be an accelerator frame. Here downwards mg is acting. So therefore the G effective m into G effective, that is the net force. The net force, that is mg effective, that is equal to m g sine alpha whole square root of mg sine alpha whole square plus mg whole square. Therefore, G effective, that will be equal to G into square root of 1 plus sine square alpha plus sine square alpha. So it moves down without friction. Mg sine alpha is also active. Downwards there is mg. So with respect to the ground frame, mg is acting. So therefore the time period will be 2 pi root over L by G only. Here with G effective, that is equal to We have to use the value of G with respect to the frame. This will be it will like this. So this way, that is G cross alpha and G cross alpha. This is NG. So here the G effective, that will be G cross alpha only. So therefore, 2 pi root over L by G effective. So that will be 2 pi root over L by G cross alpha. So option A is the correct answer. And here it is told, assume there are two identical simple pendulum clocks. Clock one is placed on the earth and clock two is placed on the space station located at a height h above the earth's surface. Clock one and clock two operate at time periods 4 seconds and 6 seconds respectively. Then the value of h is. Yeah. So the time period on the earth's surface, that is 2 pi root over L by G, that is T1, let's say, so that is 4 seconds. And T2, that is placed on the height h of surface, so that is 2 pi root over L by G dash. So that is G into R square into R plus H whole square. That is R plus H by R times of T1, and that is 6 seconds. So then H will be how much? So we can see that R plus H by R into 4, that is equal to 6. So 2 to the 4 to 3 is 6. So I can say R plus H into 2, that is equal to 3R. So therefore 2R plus 2H, that is equal to 3R. So 2H is equal to R. So H is equal to R by 2. So the radius of the earth is 6,500 kilometer. So the height will be height of the earth's surface, that is 3,200 kilometer. So option C is the correct answer. It is told when a particle executes simple harmonic motion, the nature of the graph of velocity as a function of displacement will be. So we can see that v square equal to, that omega into omega square into a square minus x square. I can say v square by omega square plus x square, that is equal to a square. I can say v square by a square omega square plus x square by a square, that is equal to 1. So it is forming, so the v versus x graph is an ellipse. Graph is an ellipse. So it is an elliptical graph. Option B is the correct answer. When it is told that in figure A, mass 2n is fixed on a mass m is attached to two springs of spring constant k. Figure B, a mass m is attached to two springs of spring constant k and 2k. If mass M, let me speak to this. If mass M in A and B are displaced by distance x horizontally and then released, then time period T1 and T2 corresponding to A and B respectively follow the relation. So here, if the time period is T1 and here the time period is T2, then you have to find the relation between T1 and T2. Simply their ratio we have to find out. So T1, let's say that it's equal to 2 pi root over 3m by k equivalent, and T2 that will be equal to also 2 pi root over 3, m by k equivalent. Now k equivalent here in the part A, that is 2k, and k equivalent in the part B, that is equal to 3k, k plus 2k. So therefore T1 that is equal to 2 pi root over 3m by 2k, and T2 that is equal to 2 pi root over n by 3k. Therefore T1 by T2 that is equal to T1 by T2 that is equal to nothing but root over 3m by 2k divided by root over m by 3k. This will be root over 3m by 2k into root over 3k by m. So k will get cancelled and m will get cancelled, and 3 by root 2. So T1 by T2 that is equal to 3 by root 2. Option A is the correct answer. Here it is told the motion of a simple pendulum executing SHM is represented by the following equation. Y is equal to A sine omega t, A sine pi t plus phi. But time is measured in seconds, then the length of the pendulum is. So t equal, so the time period is 2 pi root over L by G. Now that is equal to, so here omega is pi. So therefore this is equal to 2 pi by omega, equal to 2 pi by pi. So that is 2. So therefore 2 pi root over L by G, that is equal to 2. So therefore 2 will get cancelled. So pi square L by G, that is equal to 1. So the length of the pendulum will be equal to G by pi square. L will be equal to G, that is 9.8 divided by pi square, that is also 3.14 into 3.14. So it will come in meters, but we need in centimeters, so we will into 100 centimeters. So it is approximately, so it is approximately equal to 9.8 only. So this is 9,800 divided by pi square centimeter. Sorry, this is 980 by pi square centimeter. Nine eighty divided by pi square, that is approximately 99.3 centimeter. So means 99.4 centimeter. Option C is the correct answer. So motion of a particle in xy plane is described by a set of following equations. It is x equal to 4 sine pi by 2 minus omega t into m. So it is told motion of a particle in XY plane is described by x equal to the following equation. The path of the particle will be so x equal to 4 sine pi by 2 minus omega t in meters. Y is 4 sine omega t in meters. So here x I can write it as so sine pi by 2 minus theta is cos theta. So 4 cos theta I can say. So 4 cos omega t meter and y is 4 sine omega t. Right? So then x square plus y square if you do, then we will get 4 square cos square omega t plus sine square omega t. So this will be equal to 4 square, that is 16. So x square plus y square equal to 16. So the path of the particle will be elliptical. So option D is the correct answer. And here it is told the equation of a particle executing simple harmonic motion is given by x equal to sine pi 50 plus 1 by 3 meter at t equal to 1 second, the speed of the particle will be. So the speed v equal to dx by dt, it will be equal to cos pi t plus 1 by 3 into pi. So at t equal to 1 second, the speed v will be cos pi into 1 plus 1 by 3 meter per second. This is cos pi is also there. Pi cos pi into 1 plus 1 by 3. So pi cos 4 pi by 3 meter per second. So pi plus theta, pi plus pi by 3. So pi plus theta means it is in the third quadrant, so it will be negative. So speed is only half, so mod of g will be there. So this pi into cos pi by 3 per second, or this it is in it's in centimeter per second we have to find out. So this into 100 we have to do into 100 in centimeter per second. So this will be 100 pi, that is 3.14 into cos pi by 3, that is half. So this is 1.57 into 100. So 157 centimeter per second. Option B is the correct answer. The, the displacement of simple harmonic oscillator after 3 seconds starting from its mean position is equal to half of its amplitude. The time period of harmonic motion is the displacement of simple harmonic motion. The displacement of simple harmonic oscillator after 3 seconds. The displacement of simple harmonic oscillator after 3 seconds starting from its mean position equal to half of its amplitude. The displacement is how much after 3 seconds. So at t equal to 3 seconds, starting from its mean position is equal to half the amplitude. Means x is equal to a by 2 at t equal to 3 seconds, and at t equal to 0, it is starting from its mean position. Means the displacement is 0 at t equal to 0, and the time period of harmonic motion is. We know that x equal to, then it will be a sine omega t, where omega is 2 pi by t. T is the time period of the assumption. So a by 2, that is equal to a sine omega into at t equal to 3, so you have the 3. We cancel, so therefore 3 omega, that is equal to pi by 6. Since is equal to sine pi by 6, since sine pi by 6 is only equal to half. So 3 omega is pi by 6, so omega equals to pi by 18, pi by 18. So therefore, t is equal to 2 pi by omega, that is 2 pi by pi by 18. So it is 36 seconds. So therefore, the time period of the harmonic motion is 36 seconds. So option D is the correct answer. Then here it is told the time period of simple pendulum in a stationary lift is T. The time period of a simple pendulum in a stationary lift is T. If the lift accelerates with g by 6 vertically upwards, then the time period will be. So then G effective will be g plus g by 6. Since when it is accelerating upwards, then the normal reaction will increase. That is, so this will be normal, it is accelerating upwards. So I will say n minus mg, that is equal to ma. So n will be equal to m into g plus a, and that is equal to m into g effective. And so g effective, that is equal to g plus g by 6, that is 7g by 6. So therefore, now the normal reaction is 7g by 6. Therefore, the time period, that is equal to 2 pi root over n by g effective. This will be 2 pi root over t dash, I can say, the new time period, that is n by 7g by 6. And the time period in a stationary layout, that is 2 pi root over L by g. So therefore, I can say t dash, that is equal to 2 pi root over L by g into root over 6 by 7. This is root over 6 by 7 into t. Option C is the correct answer. And here it is told two massless springs with spring constants 2k and 9k carry 50 gram and 100 gram masses at their free ends. Two massless springs with spring constant 2k and 9k carry 50 gram and 100 gram masses at their free ends. Two massless springs are there. Spring constants 2K and 9K. They carry 50 gram and 100 gram masses at their free ends. The two masses oscillate vertically. So here the mass is 50 gram and the spring constant is 2K. Here the spring constant is 9K. The mass attached is 100 gram. The two masses oscillate vertically such that their maximum velocities are equal. Maximum velocities are equal. So V max is same. That is, so I can say A1 omega 1 that will be equal to A2 omega 2. And the ratio of their amplitudes will be, so I can say A1 by A2 that will be equal to omega 2 by omega 1. Now omega, I can say omega is 2 pi root under m by k. 2 pi root over m by k. Now therefore omega 2 by omega 1 that will be equal to root over m1 by k1 by root over m2 by k2 by root over m1 by k. So which is equal to root over m2. If I take this is n, then this is obviously 2n. So say that m2 by k2, m2 is 2n by k2 that is 9k divided by root over m1 that is m by k that is 2k. So this will be root over 2m by 9k into root over 2k by m. Therefore, m will get cancelled, k will get cancelled. So this is root over 4 by 9, which is equal to 2 by 3. So the ratio of their amplitude is 2 is to 3. So option D is the correct answer. Then it is told the metallic block of a simple pendulum has the relative density 5. The time period of this pendulum is 10 seconds. If the metallic blob is immersed in water, then the new time period becomes 5 root x seconds. The value of x will be the metallic blob of simple pendulum has the relative density 5. Time period of this pendulum is 10 seconds. Okay, so the time period is 2 pi root over L by G. And then if the metallic blob now that is immersed in water, so now the new time period that will be how much? So here the G effective we have to use. Now this is mg and this is T. The T obviously the upthrust will act, that is E rho G. E sigma, yeah, E sigma G I can say. Now rho by sigma that is equal to 5 it is told. Means sigma is the density of water. So rho is equal to 5 sigma. Rho is the density of the metallic ball. So therefore, I will say that tension is equal to mg minus E sigma G. That is equal to n into G effective. Now, therefore, the new time period T dash that is equal to 2 pi root over L by G effective. Now, G effective, so G effective that will be equal to mg minus, that will be G minus E sigma by m into G. Now, V volume is mass by density, m by rho. So therefore, this I can say G into E by m, that is 1 by rho. So into 1 minus E sigma by m. So E sigma by m that will be equal to sigma by rho. which is equal to 1 by 5. Rho by sigma is 5, so 1 by sigma by rho is 1 by 5. So 1 minus 1 by 5. So that is 5 minus 1, so 4g by 5. So therefore t dash will be equal to 2 by root over n by 4g by 5. So this is equal to root 5 by 2 into root over into 2 pi root over n by g. So that is, so here it is told t is equal to 10 seconds. So therefore this is equal to root 5 by 2 into 10 is 2 by 7. So this is 5 root 5 seconds. So the new time period t dash is, it is told that is 5 root x second. It is same as 5 root 5 seconds. So x is equal to 5. So the value of x will be 5. 5 is the answer. And here it is told the potential energy of a particle of mass 4 kg in motion along the x-axis is given by u equal to 4 into 1 minus cos 4x joule. The time period of the uh, particle for small oscillations is time period of the particle for small oscillation is. So its mass is 4 kg. Period sin theta is approximately equal to theta is pi by k second and one of k is. So as we know, force is equal to minus du by dx. So this will be minus d by dx of 4 minus 4 cos 4x, which is equal to minus of 0 minus 4. So this will be minus 4 sine 4x is equal to minus 16 minus 16 sine 4x. Force is equal to minus 16 sine 4x. Now, theta is very small, so 4x sine 4x, I can say it is approximately equal to 4x. So therefore, the force will be equal to minus 16 into 4x, that is equal to minus 64x. Is approximately. So now, therefore, it is equal to minus kx. Therefore, the time period for small oscillation that is given as 2 pi root over n by k. Therefore, here k is equal to 64 and mass m is 4 kg. So this is 2 pi root over m 4 by 64. 64 by 64 is 2 pi by root 16, that is 4. It's equal to pi by 2 seconds. So therefore, the value of k is 2, since it is told that the time period is pi by k seconds. So, so k is equal to 2. So the answer is 2. Value of k is 2. Then it is told a mass 0.9 kg, mass 0.9 kg attached to a horizontal screen executes SHM with an amplitude A1. When this mass passes to the mean position, another then a small mass of 124 kg is placed. 124 kg is placed. 124 gram is placed over it, and both masses move together with amplitude A2. Then the ratio A1 by A2 is, then the value of A1 by A2 is alpha by alpha minus 1, and the value of alpha will be. Now, So when another small mass is placed over it, then the momentum will remain conserved. Momentum will remain conserved. So there is no force acting. So I will say M V1 that is equal to M1 V1 that is equal to M2 V2 means M1 that is M that is 0.9 kg into, or I can say, 124 gram means 0.124 gram has been added. So 0.124 kg has been added. So maximum velocity at the main position, that is A1 omega 1, which is root over k by m, orbital spring, root over k by m1. Means I will say that it is m1 into root over a into root over k by m1, k1, that is equal to m2 into a2 into root over k by m2, a omega. So root k and root k will get cancelled. Then I will tell that a1 into root m1 that is equal to a2 into root m2. So therefore a1 by a2 that will be equal to root over m2 by m1. So that is root over m2 that will be equal to 1.024 divided by 0.9 is equal to, you can say this is 1024 divided by 900. Now 1024 is 2 power 10, 2 power 5, that is 4 8 are 32. So that is 32 by 50. 32 by 30, so 2 15s are 30, 2 plus 16s are 32. So this is 16 by 15. So therefore 16 by 15, that is told that it is alpha by alpha minus 1. So therefore alpha is equal to 16. So 16 is the answer. And here it is told as per given figures, two springs of spring constants K and 2K are connected to mass M. If the time period of oscillation in figure A is 3 seconds, and the time period of oscillation in figure B will be root x. So here the time period T2 that is root x seconds and T1 that is equal to 3 seconds. Then x will be how much? So here T1, um, here actually same extension will happen in both the springs. So here the force will be equal to kx. So here k equivalent will be the sum of the spring constant, that is 3k, but here the k equivalent will be equal to, I will tell since why here the sum of the extensions will be the net extension. So force by k, then tell 1 by k1 plus 1 by k2 that is equal to 1 by k equivalent here. So I will say k equivalent will be equal to k1 k2 means k into 2k by k1 plus k2, that is k plus 2k. So this is 2k square by 3k. So this is 2k by 3. So now therefore time period t1 that is equal to 2 pi root over l by 2 pi root over n by k equivalent which is equal to 2 pi root over n by 2k by 3. Means 2 pi root over 3n by 2k, that is told it is equal to 3 seconds. Then T2 will be how much? T2 will be equal to 2 pi root over m by k equivalent, that is 3k. So this will be from here I can say, T1, that is 3 seconds. So I can say root over 3 by 2 into 2 pi root over m by k, that is equal to 3 seconds. So therefore 2 pi root over m by k, I can say this is equal to 3 to root over 2 by 3. So this will be, therefore T2 that is equal to 2 pi root over, I can say m by k into 1 by root 3. 1 by root 3. So this is 2 pi root over m by k is 3 into root 2 by root 3 into 1 by root 3. So 3 and 3 will get cancelled. So this is root 2 seconds. And which is told that it is root x seconds. So x will be equal to 2. So 2 is the answer. And here it is told body is performing simple harmonic motion with an amplitude of 10 centimeter. Amplitude is 10 centimeter. Then the velocity of the body was tripled by air jet. Velocity of the body was tripled by air jet when it is at 5 centimeters from its mean position. A new amplitude of vibration is root x centimeter, then the value of x is. Our body is performing simple harmonic motion with an amplitude of 10 centimeters. So the amplitude will be 0.1 meter. The velocity of the body was tripled by air jet when it is at 5 centimeters from its mean position, and the new amplitude is. So velocity is given as omega root over a square minus a square minus y square, and where y is the uh, y is the it, 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 it displacement, y is the displacement from the mean position, displacement from the mean position, and a is the amplitude. Now it is told velocity has been tripled. So here y is 5 centimeter. So we will come in centimeter per second. If I take a and y in centimeter, then the velocity will come in centimeter per second. So I can say that the amplitude is 10 only, 10 centimeters. So I will say that v dash, the new velocity, that is omega, will not change since k and m is not changing. Omega into root over a dash square, or I can say a1 square minus y square. That is equal to 3 times the velocity of the body is tripled. That is 3 omega into root over a square minus y square. So omega and omega will get cancelled. So if I square it, then I will get a1 square minus omega y square. That is equal to 3 or 9 into a square minus y square. So therefore, if y is 5, so a1 square minus 5 square, that is equal to 9 into 10 square minus 5 square, which means a1 square, that is equal to 5 square plus 9 into 100 minus 25, that is 75. 15 into 5, 75. So therefore, I can say this is 25. So a1 square, I can say that is 25 into 1 plus 25, 3, 3 9 is 27. It's 28. Therefore, a1 square is 25 into 28. 25 into 28. Density of the body is tripled when it is at 5 centimeter. The displacement new amplitude of the vibration. So yeah, so this will be A1 square is 25 into 28. So you can say it is 25 into 4, 7s are 28, 25 4s are 100, so 100 into 7, that is 700. So A1 will be root over 700 centimeters. So the new amplitude will be root of 700 centimeters. So this is told this is root x. So x will be 700. Well, the value of x is 700. And it is told a pendulum is suspended from by a string length 250 centimeter. Mass of the bob of the pendulum is 200 grams. The bob is pulled aside until the string is at 60 degree with vertical as shown in the figure. After releasing the bob, the maximum velocity attained by the bob will be mass of the bob is 200 grams, that is 0.2 kg. The length is 250 centimeter, means it is which is 2.5 meter. The bob is pulled aside 60 degree with vertical. After releasing the bob, the maximum velocity attained by the bob will be okay. So here it will attain the maximum velocity v. Here it is at rest, is being released here equal to 0. So here simply I will tell we have to apply work done by gravity is equal to the increase in kinetic energy. So work done by gravity is equal to mgh, that is equal to half mv square. So v square is equal to 2gh. Now h will be how much? H will be equal to L. This is L cos 60, L in L minus L cos 60. Cos 60 is half, so L minus L by 2, that is equal to L by 2. So it means V square will be equal to 2g into L by 2. So L2 will cancel, so it's equal to gm. So therefore, the maximum velocity attained V will be equal to root gm. Root over g, that is 10, 10 into L, that is 2.5. So that is root over 25. So that is 5 meter per second. So 5 is the answer. Then here it is told uh, particle executes simple harmonic motion. Its amplitude is 8 centimeter and its time period is 6 seconds. The time it will take to travel from its position of maximum displacement, the time that it will take, that is delta t, which is the time interval that it will take, that we have to find out. The time it will take to travel from its position of maximum displacement, means from x equal to a to the point corresponding to half its amplitude is. So till x equal to a by 2, how much time it will take, that we have to find out. So therefore, you can say x is equal to a sine omega t, which is the equation of motion of the SHM. If we assume that at t equal to 0, x was equal to 0 only, means initially it was at the mean position. Initially it is at the mean mean position only. So then x will be equal to a at each time, x equal to a sine omega t. So that is, it means that omega t that should be equal to pi by 2, since sine pi by 2 is equal to 1. So sine pi by 2 is 1. So t will be equal to pi by 2 omega a by 2. A by 2 is a sine omega t. So therefore, omega t that should be equal to either pi by 6, since at pi by 6 it is half, or I can say at 5 pi by 6, means at pi minus pi by 6. In sine pi minus pi by 6 is, since sine pi minus theta is same as sine theta only. So we know that so t can be either pi by 6 omega or it can be 5 pi by 6 omega. Now this t is obviously pi by, we can say it is 3 pi by 6 omega. So therefore pi by 6 omega we can't have, 5 pi by 6 omega only we should have, since why? This is actually t plus delta t, we can call it as t1. So at t1 equal to t plus delta t, since why t1 should be more than t obviously, since why initially it is told it is coming from x equal to a to x equal to a by 2. So it means that if this is at time t, then this should be at a, a later time. So t1 should be obviously more than t. So therefore, delta t, that is t1 minus t, so that is 5 pi by 6 omega minus 3 pi by 6 omega. So that is, so t, that is delta t, which is the time interval, that is 2 pi by 6 omega, that is pi by 3 omega. Now the time period has been told 6 seconds. So t, that is 2 pi by omega, 3 pi by omega is 6. So therefore pi by omega, that is equal to 3. So this we can say, so delta t that will be equal to pi by omega by 3. We can say pi by omega by 3. So that is t by 3, that is 1 second. So it will take 1 second to travel from its position of maximum displacement, that is from x equal to a, to the point corresponding to half its amplitude, that is equal till x equal to a. It will take 1 second. So one is the answer. Then here it is told a mass of 5 kg is connected to a spring. The potential energy of this, the potential energy curve of the simple harmonic motion executed by the system is shown in figure. So you will be equal to half kx square. A simple pendulum of length 4 meter has the same period of oscillation as the spring system. Simple pendulum of length 4 meters. So t will be equal to 2 pi root over L by G, that is 4 by 10. So here this should be actually x minus 2 whole square, since here the mean position is at x equal to 2. So the potential energy is half k into x minus 2 whole square. Uh, then what is the value of acceleration due to gravity on the planet where these experiments are being are performed? So this g value we have to find out. G, let's say G1. G1 is the acceleration due to gravity on that planet. So then G1 we have to find out. So here we can see that half k a square. So here we can see that the amplitude is 2 meter. Mean position is at x equal to 2. and the maximum potential energy, which is equal to half a square, that is equal to 10 joule. And from here we can find out k. Then time period here we can also find out just 2 pi root over m by k. M is 5, so we will 2 pi root over 5 by k. So now k, that is so half into k into 2 square, that is equal to 10 joule. So 2 joules of force, so k will be equal to 5. K is 5, so this is equal to 2 pi seconds. Therefore, I can say 2 pi is so 2 pi will be equal to 2 pi root over 4 by g1. And 2 pi will get cancelled. So root over 4 by g1, that is equal to 1. So therefore 4 by g1, that is equal to 1. So g1 will be equal to 4 meter per second square. The acceleration due to gravity on that planet where these experiments are being performed is 4 meter per second square. So option C is the answer. And here it is told. Here it is told that a bob of mass m suspended by a thread. Bob of mass m suspended by a thread of length L and this mass is m. Undergoes simple harmonic oscillations with time period t. If the bob is immersed in a liquid that has density 1/4 times of that of the bob, so sigma is equal to rho by 4. And the length of the thread is increased. Length L dash is increased by 1/3 of its original length. So it will be now L plus L by 3. Then the time period of these simple harmonic oscillations will be means t dash. The new time period will be how much in terms of the old one. So the old time period when it is kept in air, when it is kept in air, the time period. So t dash is the time period in the liquid which is having density rho by 4, where rho is the density of the dot. So T will be equal to 2 pi root over L by G. And here T dash will be obviously 2 pi root over L dash, the new length by G effective. Now G effective that we know, G effective, mg effective, that is equal to mg. Here tension is acting here, V rho G, E sigma G, which is the buoyancy force. The buoyant force or the upthrust will act on the bob when it is kept in the liquid. Now mg effective, that is same as the tension, which is equal to mg minus b sigma g. Now volume I can say that is mass by density m by rho. So this will be mg effective, that is equal to mg minus m sigma by rho into g. So therefore G effective, that is nothing but G into 1 minus sigma by rho. Now sigma by rho from here, sigma by rho, that is equal to 1 by 4. So this is G into 1 minus 1 by 4. So that is 3 by 4, 3G by 4. And L dash, the new length is L plus L by 3. So it is 4L by 3. So therefore the new time period T dash, that is equal to 2 by root over L dash, that is 4L by 3 divided by G effective, that is 3G by 4. That means this will be 2 pi into root over L by G into 4 square by 3 square is equal to 4 by 3 into 2 pi root over L by G. Four pi into 2 pi root over L by G. 4 by 3 or 2 pi root over L by G. So now P dash is 4 by 3 times the time period, that is T. So it is 4 by 3t. So t dash is 4 by 3t. So option D is the correct answer. It is told for a body executing SHM, potential energy is always equal to its kinetic energy, which is false since potential energy is half kx squared and kinetic energy is half k into a square minus x square. So they are not always same. So average potential and average kinetic energy over any given time interval are always equal. The average potential energy, the average kinetic energy, they are equal. Yeah, that is true. For a given time interval. Since y x is equal to x square will be a square sine square omega t and a square minus x square that will be equal to a square cos square omega t. So the average of sine square omega t is same as the average of cos square omega t, that is equal to half. So therefore the average of potential energy and the average of kinetic energy over a given time interval, that is given, that will be obviously 1 by 4 k a square. Since average of x square is also a square by 2, average of a square minus x square is also a square by 2. So 2 is, the second statement is true, first one is false, and 3 is sum of the kinetic and potential energy at any point of time is constant. Yeah, that is obviously true, since y kinetic energy plus potential energy, that is equal to half a square always, which is a constant. So third one is also true. And average kinetic energy in one time period. Okay, average potential and kinetic energy over any given time interval are equal. That is false. Since why? If we take over one time over one time period, then that will be same. Over one time period, then only that will be same. Since why the average of sine square omega t and average of cos square omega t is half. Only in a given, only for if the time is an integral multiple of the time period, is 2 pi by omega. If t is n into 2 pi by omega, then only it will be half, else it will not be equal to half. So the second statement is also false. But average kinetic energy in one time period is equal to the average potential energy in one time period. That is true, which is equal to half, which is equal to 1 by 4 k square. So only 3 and 4 are the most appropriate option for the in the options. So option A is the correct answer.